Good morning, everyone. Our chapter today is chapter 2, Electrochemistry. It is oxidation and reduction reactions. We know that we have two reactions. One is oxidation and the second is reduction. Each one has a change in the number of electrons, loss or gain, and will give us a product. It is an ion or a metal. The oxidizing and reducing agents. This is a reaction between Cu metal and Ag plus ion. We have a Cu strip embedded in the Ag plus ion beaker. This is the Cu strip and these are the Ag plus ions present in the beaker. After certain time, a reaction occurs between Cu and Ag+, because there are changes that occur. Upon change, we know that a reaction has occurred. The change can be in color, can be in formation of deposit, can be in a gas, or according to the reaction. Here, the color of the solution changes from colorless to blue. Thus, a reaction has occurred and a deposit is formed indicating Ag formation. As you can see here, the deposit of Ag is formed on the Cu strip. Also, Cu2 plus is formed. Cu2 plus ions is formed and this changes the solution color to blue. There is a rise in temperature by the thermometer indicated and this reaction is exothermic. It releases energy because there is an increase in temperature. Also, the mass of Cu decreases because the Cu strip becomes thinner, so where the Cu mass decreases. Thus, a reaction has occurred between Cu and Ag+. Cu has changed into Cu2+. This change from the metal to the ion, we have release of 2 electrons. So Cu gives Cu2+ plus 2 electrons. This is called oxidation half reaction. So oxidation half reaction occurs when there is release of electrons, which means there is loss of electrons. While Ag plus transforms into Ag because we've seen Ag deposit on the beaker on the Cu strip. Okay, Ag plus gains 1 electron to become Ag. This is a reduction half reaction. There is gain of electrons. So Ag plus 1 electron gives Ag. This is the reduction half reaction. To get the overall reaction, we should have the same number of electrons in both half reactions. So we multiply the second reaction by 2 to get 2 electrons here. Thus the overall reaction will be Cu plus 2Ag plus gives Cu2 plus 2Ag. This is the overall reaction obtained from oxidation and reduction half reactions. So we can say that redox reaction has oxidation and reduction. An overall reaction that contains both half reactions is called redox reaction. Oxidation is a process in which there is loss of electrons. For example, M gives Mn plus N electron. The metal changes to ion. While reduction is the process which involves gain of electrons. Mn plus N electrons give M. The metal is transformed into ion. Okay, and these are the two half reactions. Now, regarding oxidizing agent and reducing agent. The oxidizing agent is the species that undergoes reduction. It means here in this reduction, Mn plus is oxidizing agent, while reducing agent is the species that undergoes oxidation. It means here M is reducing agent. Okay, they are inversed. The oxidizing agent undergoes reduction, while reducing agent undergoes oxidation. For example, here A is reducing agent, it undergoes oxidation. Okay, it loses electrons, while B is oxidizing agent, it undergoes reduction. Redox couples. The redox couples of a metal are represented by Mn plus M. It is formed from the oxidizing agent Mn plus and reducing agent M. It means that Mn plus N electrons gives M. If we take the first reaction, there is gain of electrons. It means that it is reduction. And the second one here, this arrow, if we take it, M gives Mn plus plus n electron, it is oxidation. So Mn plus M is the redox couple. If I said write a redox couple, you write first the oxidizing agent and second the reducing agent. It means oxidizing agent, I mean the ion which undergoes reduction, Mn plus. The second one is the metal which undergoes which is the reducing agent that undergoes oxidation. Always it is written in the form Mn plus M. For example, Al3 plus 3 electron gives Al. The redox couple is Al3 plus slash Al. You write first the ion, then the metal. The Al3 plus is the ion that undergoes reduction, and Al is the metal that undergoes oxidation. Cu gives Cu2 plus 2 electron. You write first Cu2 plus slash Cu. Okay, you always write the redox couple in the form of the ion slash metal. Always the ion is the one that undergoes the reduction. It is called oxidizing agent, and the metal is the one that undergoes oxidation. It is the reducing agent. You write oxidizing agent slash reducing agent. The electrochemical classification of redox couples. This classification arranges the oxidizing agent and the couples according to the increasing order of oxidizing power and reducing agent according to an increasing power. I mean by that, you have this axis. Okay, this axis shows us redox couples, Au3 plus Au, Ag plus Ag, Cu2 plus Cu, etc. If we move from below to above, it means by this arrow, we have increasing oxidizing power. It means as I move from Mg2 plus to Au3 plus, the oxidizing power increases. It means that Au3 plus has the highest oxidizing power. It means to oxidize other agent. Okay, Au3 plus has the highest oxidizing power. While in the second axis, okay, or the second part of the axis, we are moving downwards, increasing reducing power. It means as I move downward, the reducing power increases. It means Mg has the highest reducing power, while Au3 plus has the highest oxidizing power. This is because we are working with reactive elements. We want to know which two elements are reacting together. It means which metal with which ion will react and form a reaction. This axis will be given in every exercise in order to work on it. I'll show you how we will work on this axis. Okay, but you should know first that the electrochemical classification, we have an axis where elements are arranged, or redox couples are arranged, in which we have increasing oxidizing power as I move upwards and increasing reducing power as I move downwards. Okay, gamma rule. Gamma rule, we work on a strong oxidizing agent with a strong reducing agent. Gamma rule is represented by this shape. It means like this. Okay, this is gamma rule. Gamma rule, it is used to predict reaction between the metal and metal ion. The spontaneous reaction occurs between the two couples Mn plus and M. Okay, with M2, Mn plus and M2 occurs between the stronger oxidizing agent and the stronger reducing agent. It means according to this axis, I make gamma rule on the axis, I see that strong oxidizing agent react with this strong reducing agent and not the opposite. I can't say that the reaction occur between these two reactants, the weak one. Okay, the reactants are the strong oxidizing agent with the strong reducing agent. It means I apply gamma rule on the axis and then I write strong oxidizing agent plus a strong reducing agent gives weak oxidizing agent plus weak reducing agent. While opposite gamma rule doesn't proceed, we cannot work on the opposite. You make gamma rule and then you see which are the strongest one that will react with each other. The strong oxidizing agent with the strong reducing agent. Example, here we have this axis. We have AU3 plus AU, AG plus AG. So I make the gamma rule, and AU3 plus will react with AG because AU3 plus is the strong oxidizing agent and AG is the strong reducing agent. So to balance it, we have to write the half reactions. We do not directly write the overall reaction. We write AU3 plus 3 electron gives AU. Why did I write this reaction in the form of gaining electron or reduction? Because AU3 plus is present here, and here it is the side of oxidizing agent. Oxidizing agent, so it undergoes reduction. I write AU3 plus 3 electron gives AU. And Ag is on the side of reducing agent. It is a strong reducing agent. Okay, Ag undergoes oxidation, gives Ag plus 1 electron. Times 3 to balance, then this is the overall reaction. The balanced equation of oxidation reduction represents the overall reaction between two redox couple. So we have to write the balanced equation. We do not write directly the metal and the metal ion from the gamma rule. We have to write the half reactions and then the overall equation. It's very important to know which two reactants will react with each other according to the gamma rule. And always the oxidizing agent undergoes reduction. We write the reduction half reaction, and the reducing agent undergoes oxidation. You write it.